This is lesson 24, which is on the angle, side angle, and side congruence criteria for triangles. To start with, let's talk about exactly what is ASA and SSS and how does it look as far as two triangles. So let's start with ASA. ASA stands for angle, side, angle. And a picture would look something like this. You'd have two triangles. Here's one. And here's another one. And we're trying to determine if they're congruent or not. So we start by finding corresponding sides and seeing if the corresponding sides are congruent, finding corresponding angles, seeing if they're congruent or not. And we end up with a pattern that looks something like this. We found a pair of corresponding angles, say maybe this angle and this angle, which are congruent to each other. Then we find a pair of corresponding sides, maybe this side and this side, which are also congruent. And then we find another pair of angles that are congruent. And if we look at it, see how the side is in between the two pairs of angles. So this is angle, side, angle. We have angle, side, angle, and angle, side, angle. Okay, then we could say that those two triangles, which we'll call A and B, those two triangles are congruent to each other. So we could say triangle A is congruent to triangle B by angle, side, angle, congruence criteria. And the second one, which I think is probably the easiest one to do, is the SSS criteria. And SSS stands for side, and side. So what that's saying is if you can match up all three pairs of corresponding sides, then you have the two triangles are congruent to each other. So we'll start with, let's do one triangle here. We have another triangle here. And let's say this side ends up to be congruent to that side. And then we do some more work and we figure out that this side is congruent to this side. And then the last pair of sides are also congruent to each other. So this would be an example of side congruency. So we could say that triangle A is congruent to triangle B by SSS. This next part of the note is asking us to determine whether a congruence exists between some triangles. If the congruence exists, state the congruencies and the criteria used to determine them. So we're not doing a full-blown proof on these, but we are kind of getting close because we're still stating the different congruencies and the criteria. So let's start with number 1. So we're given that M is the midpoint of HP. The measure of angle H is equal to the measure of angle P. The way I always do these is I start by just marking on the picture all the different things that I can find that match up. So let's start with any sides that match. Alright, so right here I have M is the midpoint of HP. That tells me that M is splitting HP into two equal halves. So let's look at HP. HP is this line right here. And that M is the midpoint. That means that this side of this triangle is going to be congruent to this side. Okay, and then let's see if I can find any other matching sides, and I do not. So let's go to the next part of the given, which is that the measure of angle H is equal to the measure of angle P. So let's find those two angles. Here's angle H, and here's angle P. So those two are congruent. Okay, and then let's look at the picture and see if I can see any vertical angles or things like that. And I do see a vertical angle right here with this angle in the center. Alright, so let's see if I can find any patterns, if I can find any criteria for congruency. And I'm looking, I see an angle, a side, and an angle in this one. So let's see if I have another angle and a side and an angle. And it looks like I do. So I can say that triangle GHM is congruent to triangle, and I need to make sure I match up the corresponding points. So G is this one, and it's going to match with the R over here. So it's going to be triangle R and P and M by, and it was ASA. So triangle GHM is congruent to triangle RPM by ASA. Alright, so let's go ahead and do the next one. Okay, we're looking at number 2. It says given rectangle JKLM with diagonal KM. So I'm going to have to try to remember some of my facts about rectangles for this one. So let's see what we have right away. I know a rectangle, the opposite sides are equal to each other. So that tells me that JK is equal to ML, and then that JM is equal to KL. Okay, and then I notice I have a shared side, which is the MK right there. Alright, so looking at it right away, I can see that I have enough to do a congruency between those two triangles. I have a side, and a side here, and then a side, and a shared side there. So I can do triangle, and let's do MJK. It doesn't really matter what order I write these letters, but I need to make sure that it matches with the other triangle. So the M has to match up with the corresponding point on the other triangle, which is going to actually be point K on the other. Well, let's see. So it's going to match up with point K. And then the J is going to match up with point L. And then the other K is going to match up with the M. So it's triangle MJK is congruent to triangle KLM. And that's going to be by the side congruence criteria. Okay, number 3 says given RY is equal to RB, AR is equal to XR. So let's mark those on this picture. Let's see, we have RY is this little side right here, and then RB is this other side here. And then I have AR, which is the bigger side right here, and XR, which is right here. Okay, so let's look at the picture. I can find anything else. I see a couple vertical angles right here. I have an isosceles triangle, which is this triangle right here. So the base angles are going to be equal, but I don't think that's going to help us right away. We have a bunch of different triangles in here, so I'm just going to find one pair of congruencies. And if I look at triangle AYR, this one, and I look at triangle XYZ, BR, which is this one, I can see that I have side angle side in those. So those are the two I'm going to use. So I'm going to do triangle YAR is congruent to triangle BXR, and that's going to be by side angle side. Alright, number 4 says given the measure of angle A is equal to measure of angle D, and then side AE is equal to side DE. So let's mark those on our picture. We have A is equal to D, and that is this angle right here, and this angle. Then I have side AE is equal to DE. So AE is this side, and DE is this side. And then I need to find anything else that'll help me. And if we look at this middle angle E, it's a vertical angle. So if I look right here, this angle and this angle, those are going to be congruent. So if I look at it, I can see that I have ASA in both triangles. And the two triangles I'm talking about are triangle ABE, which is this one, and triangle DCE, which is this one. Okay, so I can write that triangle ABE is congruent to triangle DCE, and by the angle side angle criteria. Number 5 we're going to skip, so we'll end the video here.